All right, the following is the final presentation for the grocery truck project with ENDEAVR.
This diagram demonstrates how our project relies on interdisciplinary studies in order to best serve the city and people of Nolanville. As a team, we implement machine learning, urban planning, design, construction, and community outreach into our truck to ensure we maximize the success of this project.
So when undertaking this project, we have four main aims we hope to fulfill. So the primary and the most important one is to eliminate the food desert problem in Nolanville. A food desert is basically a region where there's no grocery stores in the surrounding area, which makes it very difficult for residents of that food desert to get their food. So we hope through the grocery truck we can sort of alleviate that issue. Sort of compounding off that is we hope to provide fresh produce to promote healthy eating habits. In a food desert, it's often easier for the residents to sort of fall back on junk food, so to speak, which is high calorie, low nutrient food, which leads to like health issues and just is generally promotes unhealthy eating. So we hope to change that. Another thing we hope to do is to innovate a walkable community, because right now there's a big train track that goes through town, so it makes it already difficult to walk around. Hopefully through the grocery truck, we can, park the truck and set up shop in a safe location that allows the town residents to, safely be able to walk over, do their business, and then get back home safely. And the final thing we hope to do is to bolster the sense of community by creating opportunities for social interaction. I'm sure the bonds in Nolanville are already quite tight, but basically just by, having the grocery truck there, interacting with the community, giving the community another opportunity to interact with each other is just gonna, sort of strengthen their bonds. And that's something we hope to do to improve how people in Nolanville are living.
Yeah, so at this project, we had a few industry contacts that helped us along the way. This included people from Nolanville, from different food pantries and food banks. AppGeo helped us a lot in the beginning with our initial ideation. And then we had a lot of help from the Relis campus when it came to the construction and building of our actual truck. And now we'll go on to our machine learning.
So basically the extent of machine learning in this project is, as of right now, we've created a machine learning model, which basically takes in imagery of produce, which is, what's going to be in the grocery truck, and it can successfully identify what something is. Like, for example, if you look at the photo at the bottom, it can pick out what's an apple, what's a potato, what's a carrot, something like that. So basically, when creating one of these models, it's really important to have a good data set, because the accuracy and the quality of the model depends basically entirely on the data set that it's trained with. So the data set we used is a public data set called the KUKA data set. And basically, it has 300,000 images with 80 different various object categories. These categories are basically just like a class definition, like, these are pictures of an apple, these are pictures of oranges, something like that. So that's basically a category. And the thing that's special about this data set, it's basically made for object segmentation and recognition, which again, like I mentioned, is figuring out what's what in a photo. So from this big data set, we selected images of produce data. We selected 240 images to train the model and 60 images with which to test the model. And just some other quick things. Basically, we hosted this model on Google Drive, and we use Google Colab to run the code. We do this because training a model is sort of resource intensive, and basically they have a GPU advantage, which is beneficial for us.
Okay, so moving on to the actual machine learning model, we decided to move forward with a mask RCNN. This is probably one of the most cutting edge models to date. It's extremely fast and easy to train. It already exists to run on a COCO data set, which we decided to use for our training. What makes this algorithm special is that it regionalizes certain parts of any given frame or image, and it attempts to identify certain objects that we give it to target or identify. So in our case, we're trying to identify apples, oranges, bananas, et cetera, et cetera. So as opposed to the traditional CNN model, which would identify certain frames as a binary classifier, whether or not it contained a specific object. This one's a little bit more special in that it can identify exactly how many of a target object are in any given frame, which is pretty useful given our task at hand, which is identifying how many of any given food is in a frame. So, that's particularly special for what we're trying to achieve, from which we can, identify where exactly and how many objects we have in any given photo. So as with any given set of advantages for any model, there are a set of disadvantages. In our particular case, we do have a limited number of classifiers or target images that we're constrained to. In particular, if we weren't to identify, say, for instance, yams in a image containing apples, oranges, bananas, and a yam, we'd need to do supplemental training in order to account for something like yams. So, of course, this is something we're hoping to tackle in the future.
Yeah, so now I'm going to go over just in general what the input and output of this algorithm looks like, because so far we've talked a lot about the algorithm, but we really haven't said, like, what does it look like? So in these images, you can see on the left what you would input as a user. So like a basket of apples or a bunch of oranges. And then on the right, you can see what we have for our output as of right now. We're currently working on trying to get this output to be in a more user-friendly way, hopefully through what will be our Google site that we are in the process of working on. And so I'll just use the oranges as an example because it's the first one. So on the left, you see you have 5 oranges, and the output on the right is what we get. We get our mask RCNN breaking up each individual orange and telling us what certainty each of those oranges are at. And each of these oranges had a over 90% certainty. So this certainty indicates whether or not this object is what it was classified as. So if something is 99% an apple, that means the algorithm is certain to 99% that it is an apple. But you can see in the bottom image that not all the apples are pulled out, or maybe just there's a little bit off and there's some error that you can see. But this is known in any kind of algorithm, because when you look at an apple and you see only a quarter of an apple, how is that algorithm going to know that it is an apple? They don't have all the image that you can see, and that is something that you work with an algorithm like this.
We'll be moving on to the bus construction now. So we had a few goals for our design goals for the construction of the bus. One of them was usability. We wanted this to be a food truck bus, and so we concentrated heavily on that. But also we had to worry about the multi-use aspects, because when this wasn't going to be a food truck bus, the city could utilize it in other ways. And then the third aspect we wanted to tackle was comfort level. We wanted it to be welcoming. We didn't want people to be cramped or too hot or too cold. And so we had to worry about that aspect as well. And the challenge of the construction was incorporating each one of these elements using community involvement, interior design methods, while staying within our parameters, which would be our time and our budget.
In terms of interior design elements, we started off by mapping out the inside of the bus with 2 different sections. So one side is going to be the passenger seats, which will be used for transportation when the bus isn't used for grocery trucks. And the other side is going to be a grocery aisle with fresh produce for the grocery truck functions. So at first we removed the seats in one side of the bus, and we noted to make sure we have enough space needed for the wheelchair accessibility, since on the back of the bus there is like a wheelchair ramp that will go down whenever the bus is parked. So we made sure to take note of that. And the materials we researched for renovation is one, the grocery shelves that we ordered online, and then it was modified to fit the inside since the height was a bit different. And the foldable tables and small cabinets for multi-use for the community to have more access inside. And lastly, we contacted with Pastor Warden to incorporate some of their community design preferences, either inside or outside.
So this is the final design of the bus and just some specs. I'm just gonna say 'em. We have 3 industrial grade shelves that can hold up to 900 pounds of food. You'll see that if you look at the bottom right picture, it's on the left-hand side. And then we're gonna have 6 foldable seats for the multi-use and the functionality. Essentially, when it's not being used as a food truck, it can drop people off and things like that. And then we're gonna incorporate a 3x3 foldable table and also a small filing cabinet, just so they can keep track of what the bus is doing and keep other papers in there.
So that's the exterior of the truck, and the color will remain the same. As you can see, the ramp that I talked about earlier was right here, and there's an entrance, main entrance, and so the color will remain the same, but our logo art will be added via decal.
So the goal for the exterior of our bus was to design something that was welcoming, bright, and exciting to look at. Our first thought was to design a wrap to cover the entire bus, like we'd seen in some other grocery bus projects, but we decided to keep the blue color and add on the sticker decals just because of how cost effective they are and how easy to remove they are. We figured it would be nice just for future groups that work on the grocery bus. If any of the art decals we're going to put down, if they want to remove any of those, it'll be really simple. And so we decided on Let Us Deliver as our bus name, which is displayed on side B of the bus. And the bus slogan is the grocery store like never before. And it's displayed on the back of the bus. And then we also have a couple of logos from some of our sponsors, including Nolanville First United Methodist Church and the Nolanville Food Pantry. And then this is just the design of the front and back of the bus as well.
Lastly, we're just going to talk about the community implementation of the actual bus. So overall, the intention of this project, as it first began and then will soon be released to the Nolanville community, is essentially to seamlessly implement this resource into their everyday lives. This diagram illustrates how each group of the people involved is connected to the other, and how our truck is self-sufficient with Nolanville locals once implemented into the community. Thanks so much for listening, and let us know if you have any questions.